Morning class 9th. Today we are going to do a new chapter for you after finishing expansion. Then I did factorization for you. Then I did simultaneous equations for you, problems on simultaneous equations for you. I have put those lectures on the video. Now we are going to do is indices. The next topic which we are picking up is indices. It's a very interesting topic which you have already used actually while taking out LCM. While taking out LCM, you used to get larger numbers, like you used to get 2 into 2 into 2 into 3 into 3 into 3 into 5 into 5 into 5 into 5 into 5 into 5. Now writing this way was not the way. What we used to do it, we used to count how many 2's are there. 2 to the power 3. We used to write 2 to the power 3. 3 to the power 3 and 5 to the power 5. So the shorter way of writing was this. We are talking of only 2 to the power 5, but it could be 2 to the power 100 or 2 to the power 1000. When we have larger numbers, very large numbers, then we put to the power as many as we like. We put the numbers as much as we like, and this is called the base. Like 2 is base, 3 is base here, 5 is base here, and 100, 1000 or 3 or 5 is called the exponent, or it is also called index. It is called index. There is a whole algebra of index which we are going to study. There are laws governing them, that how do we multiply, how do we divide, how do we do what. So we are going to study the algebra of indices now, because you are going to come across these things in mathematics and science, so we need to know them. Now, like I am writing a into a 3 times, so instead of writing a 10 times or 3 times, we write a to the power 3. For example, a is multiplied by itself n times. If we are going to write n times, then we simply write a to the power n. Instead of writing a n times, or any number for that matter, 100 times or 200 times or 1000 times, we write to the power 100. Very small numbers, very large numbers, it is very important to use index. If the distances are too much from here to the sun, or from here to the moon, or from here to a star, we use the distances. For distances, we use the powers. And if the weight is too less or time is very less, then to the power minus we use. Now there are laws which govern these algebra of indices. The first law is product law. Like it is a to the power m and a to the power n. The bases are same. Bases are same. Base is a, but the power is different, or index is different. So here what happens is you add up the indices. A to the power m into a to the power n will become a to the power m plus n. The powers get added. It is not restricted only to, it could be as many, a to the power x, a to the power y, a to the power z. If bases are same, powers get added. If bases are same, powers get added. The second is quotient law, division. A to the power m divided by a to the power n. Instead of addition, it becomes subtraction. A to the power m divided by a to the power n will be equal to a to the power m minus n. It becomes subtraction, quotient law. Next is power law, power to the power. If a to the power m to the power n, then we write it as a to the power m into n. We write it as a to the power m into n. Fractional indices, when it is given under the roots. For example, a and n is written here, that means a to the power 1 upon a. Only under root means a to the power half. If 3 is, it is not 3 multiplied by root a, then we write it 3 root a. But when you are writing root a and 3 is written here, that means it is to the power 1 upon 3. If it is a, like it is written m, n. So what does it mean? It means a to the power n, m to the power 1 upon n. Similarly, a to the power 5 upon 4, means a to the power 5 and under root whatever is in the denominator comes outside. Now for a non-zero number, a to the power n is equal to 1 upon a minus a to the power minus n. That means when you have to change the sign of index, then you shift it from numerator to denominator or denominator to numerator. When there is a change of sign for the index, if it is a to the power minus n, for example, and I want to make the index positive, then I must bring it in the denominator. If it is in numerator, and if it is in denominator, you bring it to numerator. Any non-zero number raised to power 0 is 1. This is very important. A to the power 0 is 1, 10 to the power 0 is 1, 1000 to the power 0 is 1. Any non-zero number risen to power 0 is always going to be 1. These are very important laws because the next chapter which we will be doing will be logarithms. In logarithms, it is absolutely related to indices, and we will be using much more of this in logarithm. We will be doing a lot of questions based on indices itself in the next video.